So good morning. This video is going to be about measuring alkalinity in the field. So you don't have to take a sample back to the lab, you just measure it straight in the field when you take your groundwater sample. And alkalinity is really just the sum total of all the alkaline species in the water, and usually it's dominated by bicarbonate, so what we're really measuring is bicarbonate in the water. So there's several simple alkalinity kits out there. There's one very good one made by Aquamerc, which comes in a pale blue box. This one by Hanna Instruments is very similar. They are very slightly different, however, so it's always worth just reading the instructions before you start. I've already done that. The principle of all these kits is that you take a known amount of water, groundwater, and in both the kits you typically take 5 millilitres. So you've got a 5 milliliter syringe here. You suck up the water from your spring or your well or whatever, and then you can simply put it into a sample container like this. If you've got a pumped borehole or a flowing groundwater source, sometimes it's better to collect a little beaker of sample so that it's easier to measure out the 5 millilitres directly. So that's what I'm going to do now. I'm just going to turn on the water. So I'll just get my sample hose. You need to run the water for about 5 or 10 minutes before you take the sample for the alkalinity measurement, just to make sure you're getting fresh groundwater and not water that's been standing around in the well for a long time. So I've already been running this morning, so I can just take a bit of water directly into my clean beaker. I'll just put that aside. I'll go and turn the water off so that we don't get flooded out. So the next stage is to take a little 5 milliliter subsample of the water to do our measurement on. And for that we use the syringe. And you've seen them do this in the hospital. You just tap the syringe to get the air bubbles out. Then you move the plunger till the top of the plunger is on the 5 milliliter mark. Don't know if you can see that there, probably not. Then when we've done that, we inject it into our measuring container there. And that's also got a little 5 milliliter mark on the side there, so we can just check that we've got the right amount of water in the container. That's fine. So then we can go on and do the measurement. I'm going to use this small syringe to measure out 5 milliliters of water. See, it's graduated 1 to 5 milliliters. There we go, so we just suck our water out of the clean container. And you've seen them do this on the programs in the hospital. You just tap the syringe to get the air bubbles out, and then you move the plunger up so the top of the plunger is at the 5. Then you can inject those 5 milliliters into your sample container, and it's got a little graduated mark on the side there, 5 milliliters, so you can check that you've got the right amount of water in there. So we have our 5 milliliter sample of water. What we do now is add a pH indicator. And in the Hanna test kit it's something called bromophenol blue. And it changes colour with pH. If the pH is less than about 4.3, that is to say more acidic than 4.3, it goes yellow. If it's higher than 4.3, more alkaline than 4.3, it goes blue. And if the pH is greater than 4.3, it means that the water has bicarbonate ions in it. So let's add a drop of the indicator and see what colour our water sample goes. Oops. There we go. The right lid back on the right bottle always helps. So our water sample has turned blue. Not surprising, most waters are slightly alkaline, so we know its pH is greater than 4.3, and we know that the water sample has bicarbonate in it. So no big surprises there. What we do now is we add, ta-da, acid to the sample. Don't worry about this. This is a very, 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 very weak solution of acid. Hanna Instruments simply call it H3811 solution, but I can let you into a secret. It's just very, very weak solution of probably hydrochloric acid. So don't panic if you get it on your skin. It's not going to burn your hand off or anything like that. It's very, very weak. If you just get it on your skin, go and wash your hands straight away, as you would do normally. But don't panic. So we screw off the top of the acid, put the top of the bottle with the rim upwards to avoid contamination. Take this syringe, which is graduated in tenths of a milliliter. Make sure the plunger is all the way down. Put it into the acid. Suck up a syringe full of acid. Before we do anything else, let's put the cap back on so we don't spill it. And we simply push the plunger down until the plunger is at 0. And then what we simply do is start adding the acid drop by drop until the solution changes colour. You can see it's beginning to change already. Ooh, almost gone. There we are, that's more or less it. It's changed to a very, very pale green. And actually I think one more drop should change it all the way to yellow. Then we read the plunger, see how much acid we've added, and we've added 0.21 millilitres of acid. So I'm going to write that down there if my assistant can tell me where I put my pen. Here we are. Just to remind myself what we got. 0.21. I've done this previously already today and I got 0.22, very similar. And I would normally do this 3 times and then take the average, provided that I got similar measurements. So it's actually as simple as that. You shouldn't be afraid of doing alkalinity and these little analyses in the field. It's far better than letting the sample sit around for 2 weeks while you transport it to a lab, because bicarbonate can change a little bit during transport and storage. So it's always best to at least do some kind of measurement in the field to make sure you've got a reasonably accurate determination.